Alright, for our second video, we're looking at more operations with radicals. We're looking at multiplication and division. For these first examples, we'll be focusing on multiplying. So, you always multiply the coefficients with the coefficients and the radicals with the radicals. So that's the numbers on the outside go together and the numbers on the inside go together. In the end, you just simplify everything. Now the distributive property works. Be sure to simplify. So that's, again, when you have something outside the parentheses to inside the parentheses, it just has to be multiplied by each piece. And foiling works. You just have to be sure to simplify. Again, foiling is kind of like double distribution. Everything in this set of parentheses needs to be multiplied by each piece of this set of parentheses. So let's look at some examples of this. We have the negative square root of 6 times 3 square roots of 6. Now, let's write out what the coefficients would be. Since we have a negative here, that's like saying negative 1 is this coefficient. On this one, our coefficient is 3. It's just the numbers that are right outside of our radical symbol. Okay, now let's write down what our radicals, our square roots are. This one, we have radical 6. And this one, we have also radical 6. When we multiply this all out then, negative 1 times positive 3 becomes a negative 3 as a coefficient. And 6 times 6 makes 36. But remember that 36 is underneath the square root. So it would be negative 3 times the square root of 36. Now the square root of 36 we can simplify down to 6. So that's where each of these pieces comes from. Negative 3 times 6 then. Now from there, negative 3 times 6 we know is negative 18. So that would be your final answer. This is the most simplified version of this expression. Let's do another one. We've got square root of 12 times the negative 2 square roots of 3. Well, on this 12, the coefficient is 1. There's nothing out there. So it's 1 times this amount. For this one, the coefficient is negative 2. For our first piece, under the square root, we have 12. On our second piece, under the square root, we have 3. When we multiply piece by piece, so coefficients become negative 2, and radicals, 12 times 3 is 36. So negative 2 times the square root of 36. Well, just like in our last case, the square root of 36 is 6, so it's negative 2 times 6. And negative 2 times 6 is just negative 12. So this would be our final answer then. For our next example, we've got square root of 5 on the outside of these parentheses, so we need to distribute it to each piece on the inside. Square root of 5 times the square root of 2, and square root of 5 times the square root of 6. When we do that, square root of 5 times square root of 2 becomes square root of 10. Square root of 5 times the square root of 6 becomes the square root of 30. Neither of these will simplify though, because we can't break any square roots out of this one. We can't break any square roots out of this one. If we go back and look at our list of perfect squares, we can't divide any of those out of these two numbers. So this is our simplified form then. This is as small as we can, or as simple as we can make this one. Let's look at our next example then. We've got in parentheses square root of 2 plus square root of 5. All of that is being squared. Now remember, when you're squaring something, it means times by itself. So we can rewrite this as square root of 2 plus the square root of 5 times another square root of 2 plus the square root of 5. That's what squaring means, just times itself. This is an example then of when we need to use FOIL. FOIL means you're multiplying each of these pieces by each of these pieces. So this square root of 2 needs to be multiplied by square root of 2, and it needs to be multiplied by square root of 5. The square root of 5 needs to be multiplied by the square root of 2, and, oops, I'm going to do this in blue. It needs to be multiplied by the square root of 5. So there's going to be 4 terms here, 4 answers. Now, square root of 2 times the square root of 2 becomes the square root of 4. We can simplify that right away. We know that's going to come out to 2. So that'll make things a little easier for us. Square root of 2 times the square root of 5 is square root of 10. That we can't simplify any. So we go on to the next one. Square root of 5 times the square root of 2 is another square root of 10. And the square root of 5 times the square root of 5 is the square root of 25. And again, we can simplify that right away, get rid of the square roots, and we'll call that 5. Now, going back to adding up our radicals here, if we have one square root of 10 and another square root of 10, this just means we keep these base numbers, or the radical numbers, and we add our coefficients. There's one of them here, and there's one of them here. So 1 plus 1 would be 2. So this actually becomes 2 square roots of 10. So we've got 2 plus 2 square roots of 10, here's 1 and here's 1, plus 5. In the end, 2 plus 5 can simplify to 7. So we'd have 7 plus 2 square roots of 10 as our final answer. Looking at our next example, we have another instance of FOILing. So we do square root of 3 times 5 square roots of 3, square root of 3 times minus square root of 4. And actually, before we even do that, we're going to simplify this. Square root of 4 we know is just 2. That'll make things a little bit easier as we're trying to FOIL things out. We just call it right away square root, or square root of 4. We'll change it to the number 2. Now, we're still FOILing to each piece, but instead of calling this a radical, we're just calling it a whole number. So we need to finish out our FOIL. Square root of 5 times 5 square roots of 3, and square root of 5 times 2. So we've got each piece being multiplied here. So let's look at our first one. Square root of 3 times 5 square roots of 3. Well, this one, coefficient, is kind of like 1. It's a hidden piece. So we do 1 times 5. It's 5. And square root of 3 times square root of 3 is the square root of 9. Now, like we did before, I'm going to simplify this right away and call it 3. So this is 5 times 3 then. We're going to move on then and do square root of 3 times the square root of 2 with a minus, so negative 2. So it's minus 2 square roots of 3. This piece we can't simplify any, at least not yet. Move on to the next piece, square root of 5 times 5 square roots of 3. Again, this has a coefficient of 1, so 1 times 5 is 5. And 5 times 3 is 15. So it's 15 under the square root. And the last piece, 1 square root of 5 times 2. Coefficients make a 2 there. Radicals make a 5 there. So this, at this point, is our simplified equation, or expression. The only thing we can really do here is do this 5 times 3 and call it 15, because none of these pieces, 3, 15, and 5, none of these can we simplify, and none of them can we combine. 3, 15, and 5 are all different, so they won't combine, and none of them can we take a perfect square out of. So this is your simplified expression. Now we're going to move on and look at division. We always want to simplify our radicals first, then cancel as we are able. So again, you cancel coefficients on top and bottom, and radicals on top and bottom. You also need to be careful of addition, and I'll show you what that looks like in a couple of our examples. In the end, you always need to rationalize the denominator for good math grammar. Basically what that means is we don't want any square roots in the denominator on bottom. And again, I'll show you how to get rid of those. So, to simplify something like the square root of 9 over 4 square roots of 16, we just simplify each radical first. Square root of 9 is 3, and the square root of 16 is 4. So it's 3 over 4 times 4, which we can simplify to 3/16. So this one was nice and easy. This will not simplify or reduce as a fraction, so this is your final answer. Let's look at one that has addition with it. So in this case, we have 4 plus 3 square roots of 3 over 4 times the square root of 4. As we simplify this, square root of 4 is just 2. So we can simplify that right away, call it 4 times 2 on bottom, which we can call 8. So now we've got 4 plus 3 square roots of 3 all over 8. Now remember, when you have fractions like this, or things with this division bar, if there's an add or subtract on top, you can break it apart into two different fractions, or two different pieces. So we're going to do that, make it look like this. 4 over 8 came from here, plus 3 square roots of 3 over 8. This is because they have a common denominator of 8, so when we're adding them, we're just putting them together and adding the top pieces. This is just kind of goes back to fraction addition. As long as there's a common denominator, you can add the numerators. So that's why in this case we could break it apart and call it something like this. Now the only thing we can simplify is this 4 over 8 has to become 1 over 2. So in the end, your final answer is 1/2 plus 3 square roots of 3 over 8. Let's look at another one then. We have 4 square roots of 15 all over 5 square roots of 6. Now in this case, root 15 and root 6, neither of those will simplify down. We don't have those. But we can break them each apart into different pieces. 4 times the square root of 3 times the square root of 5, because 15 is 3 times 5. And 5 times the square root of 2 times the square root of 3, because 6 is 2 times 3. Now, because there's no addition or multiplication, or just no addition or subtraction, it's just everything being multiplied, we can cancel things on top with things on bottom. So notice we have a square root of 3 and a square root of 3, so we can cancel those out. When we do that, we're left with 4 square roots of 5 over 5 square roots of 2. At this point, we might be tempted to think we're done, except for we have a square root in the denominator. So this is where we need to rationalize the denominator. I'm going to move this over a little bit so you can see how that looks. When we're rationalizing a denominator, what that means is we're multiplying the top and bottom by the same number. That way you're not changing it, to try to get rid of this square root of 2. So how would we get rid of a square root of 2? Well, we need to multiply by the square root of 2. Square root of 2 times the square root of 2 is just 2. So that'll mean there's no more square root there. This means we have to multiply the top by the square root of 2 as well. When we do that, this will become 4 times the square root of 10 over 5 times 2. These two pieces, the square roots canceled out, and it's just 2. Now when we look at this, we can simplify it to 4 square roots of 10 over 10. We need to simplify just a little bit more because we have this whole number 4 over this whole number 10. We can take 2 out of both of those. 4 divided by 2 is 2. 10 divided by 2 is 5. So in the end, our final answer, 2 square roots of 10 over 5. Because this is a whole number, it can't cancel out with a radical. It can cancel out with this whole number coefficient. So these are the only pieces that can cancel out. This could cancel out if there was a radical down here, but we got it so there's no radicals here. So this will be your final answer. We've got 2 more examples then. We've got square root of 3x to the 4th all over 2 times the square root 5x squared y squared. Now this one we're going to break down and do some of these pieces kind of quickly. X squared and y squared are already in squared forms, so when we do the square root of them, they just come right out. So 2 times x times y, and it leaves the square root of 5. This one, oops, those are supposed to be as exponents, y squared and y squared. There we go. Y to the 4th we can break into y squared and y squared. This will help us break it down a little bit further then. Y squared and y squared can come out to the front of the square root as y times y. So we've got y times the square root of 3x, and 2 times x times y times the square root of 5. Now, like before, because there's no adding or subtracting, we can cross out anything that we see on top with anything we see on bottom. So y and y cancel out. We don't cancel out both, just the one. On bottom, we need to get rid of this square root of 5. So we multiply square root of 5 on both top and bottom. When we do that, we get y on the outside times 3x, or times the square root of 3x times 5. Again, because this is a square root, it can all come under the square root together when we multiply it. Square root of 5 times the square root of 5 is just simply 5. So on the bottom, we still have that 2x, but instead of times a square root of 5, it's now times 5. So now the only thing left to do is simplify our pieces. Y times square root of 3x times 5. Well, that becomes y times the square root of 15x. 2x times 5 on bottom becomes 10x on bottom. Now again, 15 and 10, we might think that those can cancel out, but this is under the square root. So this is not the same as this. Same thing, the x is under the square root, so it can't cancel out with this x. This can only cancel out with things on the outside. So since there's nothing to cancel out with, this is our final answer. And now we have our last example. 3 times the square root of 5 plus a square root of 3 all over 5 square roots of 3. Now, square root of 5, square root of 3, and square root of 3, none of those simplify or reduce. So what we're trying to do is rationalize the denominator. 5 times the square root of 3 means we need to do times the square root of 3 to get rid of it on bottom. When we multiply it on top, remember that it's being multiplied by every piece on top. So we need to distribute it. Square root of 3 times square root of 3, and square root of 3 times 3 times the square root of 5. When we do that, square root of 3 times 3 square roots of 5 becomes 3 times the square root of 5 times 3, this piece here. This one and this one becomes square root of 3 times 3. This one and this one becomes 5 times square root of 3 times 3. Simplifying that down, this piece becomes 3 times the square root of 15. This piece, 3 times 3 is, I'll do that over here, 9, and the square root of 9 is 3. Same thing, 3 times 3 is 9, square root of 9 is 3, so we have 5 times 3 on bottom. Now we could simplify this right away and call it 15. I'm going to leave it as 5 times 3 to kind of help us see some more canceling later. Because we have this plus right here, we need to break this up into two pieces. So we have 3 square roots of 15 over 5 times 3 plus 3 over 5 times 3. Because we kept it as 5 times 3, it makes it a little bit easier to see how we can cancel. 3 cancels out with 3. 3 cancels out with 3. This on top then just leaves a 1, because this is like 3 times 1. So 3 over 15 is the same as 1 over 5. As we simplify this then, we're left with square root of 15 over 5 plus 1 over 5. We canceled out the 3's in each of our fractions. Now, because these have the same denominator, we can combine them again. And we'll put the 1 out front because it's the whole number part, and the 15 in the back because that is a radical part. So it's 1 plus the square root of 15 all over 5. This would be your final answer. And that'll wrap it up for lesson 7-2.